Hello, everyone. So today we will be solving a Leetcode question, generate parentheses. So let's understand what is the question is telling. Okay, so we are given an integer n, and we have to generate all the possible combinations of well-formed parentheses. So first, understand what does a question wants to tell. Okay, so here, if my n is equal to 2, so my output should be strings of this type which form two parentheses. Means the string should have two parentheses. Okay. So here as we have n equal to 2, so there are this one and this one. And another possible configuration of string is this. If let's say we have n equal to 3, so we have five possibilities. First is this one, second is this one, third is like this configuration, fourth is this, and fifth is this. So now the question is how we will give the output of it. Now first thing, before we are going to solve this question, we should see that what the constraints of the question are. So if you see here, n at most goes till 8. So what that tells, okay, so that tells is that there is something sort of recursion. Okay, and we here, as we can see, we can think of like all possible combinations and all that of thing. Okay, so whenever you see that, okay, if my n is like not up 10 is to 5 or it's 10 is to 3, you could think of it as like n is equal to 8, 32, 20. So you can think of it as recursion type. Okay, so let's move to the solution part. Okay, so how do we solve this? So here you need to think one thing is that you start from always first left, right? My thing is that you always start from left, you never start from right? Okay, you never start from this line and then you start giving like let's say right bracket is more than left. It is not that thing. First observation the clear is that my number of left should be equal to number of right? Number of left bracket should be equal to right? And another thing is that my left brackets should be greater than or equal to my right bracket. It should not be the case that, okay, your right becomes greater than your left. This is not a valid. Okay, this is not a valid. This is valid because my L is always greater than my left count of brackets will be always greater than or equal to my right. As you can see from an example here of n equal to 3, you can see is that, okay, here my L is equal to R is equal to 0. Here my L is equal to 3, R is equal to 0. Here my R equal to 1, then my R equal to R equal to 3. It's never the case that my L is less than R. Okay, so this is my first observation. Second observation is to how we solve this. See, another thing you should understand is that the string is always of even length, right? Means if your n is equal to 3, your size of string is always 6. So your size is always nothing but 2 into n. Okay, this is another observation. Okay, means if my size of string becomes 2 into n, I will stop and I will insert it into my answer. Okay. So next thing you need to understand is that how we will solve this. See, understand one thing. Let's start with this thing. Okay, so how we are going to solve this. See, let's define some variables. L is my count of left brackets, R is my count of right bracket, string is current string, and my answer is a vector of string which I have to return. Okay, see, understand my condition. So if my L is like, let's say, is greater than R, okay, means I have, let's say my n is big, n is 5, and I am at this position. So what are the possibilities of third position? There are two possibilities. Either I can have this, or either I can have this, right? Let's say my n equal to 5, so I have possibilities of this. Further, here also I have two possibilities. What I can have left, or I can have right here. So continuing only this thing, I have two possibilities. Okay. Further, if I want to let's say, if I want to further do it, what is the possibility of this? This is one possibility, right? Another is that another possibility that you can have, right? When your L count becomes equal to R, now see one thing. Now I have this thing. Understand one thing. At my fifth position, can I have right? whenever my L equal to R, can I have right bracket for the, can I insert? No, 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 I cannot insert. This is my second observation. If my L equal to R, I have only one option. What is that option? I will always insert left. Okay, so here I will always insert left. Okay, let's say my n is equal to 3. Okay, now see one thing. Now here see one thing. What should be there? See, L can maximum go till n, right? Can maximum go till n and count, and R is also maximum go till n, right? Now my L has already gone 3 now. So can here this be possible? Because now I will stop when my L is equal to 2 into n. Sorry, my size of string is L is equal to 2 into n. I will stop at that point because I have to make that string, right? But this is my wrong configuration. So another observation is that if my L is already equal to n, I have only one possibility. What is that possibility? That I will always insert a right thing. I will always insert a right bracket. So this is how I am thinking this question. That if, see, so I will wrote my observation again and I will explain. See, my first is if my L is equal to R. See, if my L is equal to R. Okay, so what I am thinking is that I have only one possibility. Okay, I have only one possibility. I will insert what? Always left. Let's say my n is equal to 3, so I will always insert left. Another case, if my L is greater than R, I have two possibilities. I have here, this is a case where L is equal to 1, R is equal to 0. So I have always two possibilities, this one or this one. Then I will see, okay, my pot is L and R, and if my L becomes n, obviously always I am operating L is greater than R, L is equal to R, so my R will never go above L. Okay, so R is always less than n, because I will stop when my string becomes of 2 length, of 2 into n. I will stop when my string becomes 2 into n, and I will insert it into my answer. Okay, so see, here L equal to n and R is less than. So what I will do, I will always insert what? This is also a case. Here L is equal to 3, R equal to 0. So I will always insert this one. I will always insert this one, right? Because now L is equal to 2, R is equal to, L is equal to 3, R is equal to 2. Now L is equal to 3, R 2, and I will always insert this one. Let's say this is the case. This is the case. Let's say so here what will be there? This one and this one. You can see here this is also a valid string. This is also a valid string. Another configuration can be like that. Okay, this is the case. This is the case. Let's say this is the case. This is a different case, right? So always what? This one and this one at this position. This is my condition number 3. I have to only handle this L equal to L is greater than R, and when it is equal to and R is less than R. Okay, so now let's try run our how I am thinking this. Okay, so I have dry run it. I have taken of n equal to 2. Okay, so my here n equal to 2. Okay, and I'm starting it with that my initial string is 0. Now first, before we will be using a backtracking concept. What does backtracking means? Means that we are having a string. Okay, now what I told you here that if my L is equal to R, what will be I am doing? Okay, yes, I will insert left one, and my L count will increase by 1. Now what? I have two possibilities. The first possibility is that what it is that I can, that still my L is not equal to what? N. Okay, so I have two possibilities. L is greater than R, and still my L is not equal to N. So I will insert left and I will insert right. Okay, then I have insert left. Now you know that what is the condition here. Here the condition is that my L is equal to N. So I have only one possibilities. This one, inserting my right and inserting my right. So this I got a string. Here, as my L is equal to R, as I said, if my L is equal to R, I have only one condition to what? To push left wala. I push left. Okay, and now my L is equal to 2, right? So I have at that point also I have only one possibility to increase, right? So I will increase this one, right? And at this point, right, when my string length is 2 into n, or I'm saying that my L is equal to n and R is my n, so I will insert in my answer and see what the recursion looks like. It goes here it goes here, it goes here, it goes here, then it comes back. So whenever my function will come back, I will delete the string from this. Whenever my function will come from here, whenever my function will come here, I will delete this string, so that after the function comes here, I can go here and I can start from this string. So I can insert from this. This is what the backtracking means. Key, you inserted this, now you again start from this string. You went and then you come back with the same configuration of the C. Okay. I've also did the dry run for n equal to 3. I have tried to explain this. See, here it was getting messed up. So if okay, so if you want to, so see, here is, you can skip it for a further part where I have written the code. So here is also like, you could say I have one possibility is f l equal to sorry, here I have one possibility l equal to r. Left one, I've inserted left. Then I have two possibility, right? Again here I have two possibility. Here I have only one possibility of inserting r. I inserted r. Okay. Here I have two possibility of inserting this one and this one. Okay. Here I have one possibility of inserting left because l is equal to r. So here I inserted. Here I have inserted left one. So you can further dry run it and you will get a better understanding of it. Okay. So let's go to the part of the code. What we're doing. So if I want to show you that what our code will take, so it will have function and will have lr on answer. Okay, so let's go to the part of the code. And okay, so here we have a vector string answer and current string is our empty. Answer is equal to our vector of strings. I will define a function. Okay, okay, so it is void. Okay, and what it will take, it will take l is count of what, left brackets, r is count of right brackets. Okay, my this answer, which okay, or let's say current string, which stores what the current string is. Okay, and we have vector of string here, which is our answer. Okay, yes, and our n, which will tell okay my where I have to stop this. Okay, and my function will be, I will start with 0 L, 0 R, right? My current is empty, my string is empty, my answer, and my n. Okay, now see. So how we have approached it. Okay, we have told you that okay, if see the first condition, or I would say base condition is that wait a minute. Okay, this is my first condition. If my string length is 2 into n, then I will insert in my answer. Simple thing. Or if you can L is equal to R is equal to n, insert in my answer. Okay, so let's go there. If my L is equal to R, okay, or current size is equal to I would say 2 into n, then I will insert it into my I will insert my current string into my answer and I will return. Okay, now I saw, okay, now next what are our conditions? See, I said you if my L is equal to R, what I have to do, I have one thing to do. What to insert left only, we saw it. So I will insert what, left bracket, and I will then go to the further function. Okay, recursion, this is what it is, and I will go what I can do further, and when I come back I will remove that string. Okay, another thing we saw, else if what, that if my L is greater than R, then I have two options. So this is my first option, right, which will be there. Second option is what, insert my back, insert right. Okay, so insert right, and here as I have inserted R, so what I am doing is that if my L is greater than R, I have two options, to insert left bracket or insert R bracket. This is what the backtracking means. I have inserted this, then I pop it, and then I drive it. This is just options, there are two options. And else what, else if you don't write it's fine, but just to tell you, else if my L is equal to n and then R is less than n. Okay, so what is the case? My R should be n. When it will become n, it will stop. this is not needed, but still it's fine. I have only one option to insert my right. Okay, so you can optimize the code. This part should not become again. You can optimize, but just to show you that okay, it is okay. That cur is I will insert this right one, and left, and then okay, when my L is equal to n, I have only one option to insert right. Okay, so let's submit it and let's see what it gets. Okay, it's compilation error. Unstart insert. Okay, unstart push score. Sorry, it should work. Okay, so why it's giving wrong? L is equal to R. Okay, here L plus 1 is there. Here we have R plus 1, and we have pop back. So what's the issue? So I got my mistake. Okay, so see, our first condition was this. Okay, our second condition was this, L equal to R, and our third was this. So what was happening was that if my L equal to n and then R is less than n, if this is executed, this should not be executed. So I just entered this return, which helped me to do that, and it's all it. And if my L is equal to R, I have only option of left wala, and this is not executed. And if these both are not there, I will I will have two options to do this and this. Okay, so yes, so this was our code, and I have explained all the parts. That if my L equal to an R less than n, I have only one option, insert right. If my L equal to I have left option only, or I have two options. Thank you. If you have any doubts, you can ask in the comment section. Thank you.